We are the PASS Application Development Virtual Chapter, and our website is at appdev.sequelpass.org. And I'm going to turn this over to Ike, who will now be presenting his talk, Continuous Integration with a Database.
Awesome. Thanks a lot for the... Yeah, can you hear me?
Yeah, I can hear you, yep.
Awesome. All right. Well, thanks a lot for the introduction. I'm excited to be here, and thanks everyone for joining me today. It's 7 p.m. in Manchester, England. I'm here delivering a SQL course, and I leave at 3 in the morning. So it's a nice kind of send-off to a great week of SQL training. My name is Ike Ellis. I'm a SQL Server MVP and the lead SQL course author and instructor for Develop Mentor. I'm also a private consultant, and I'm starting a software studio with a couple of good friends of mine who are also MVPs. We're getting started right now. It's going to be called Crafting Bytes, like B-Y-T-E-S. And anyway, we've got a lot of exciting things. So this session, we're going to focus on great software development practices like testing and source control and continuous integration and all of those good things. So when I ask people, like, hey, when do you guys deploy or when do you integrate code back in, and when do you integrate database changes back in with each other with other features and also into user acceptance testing and into production, I usually get like a variety of answers. Like, when do you deploy? That's the big question. And sometimes I hear, well, we do it when we feel like it, which basically means we don't know when we do it. We do it when our boss demands that we do it. Some people say, oh, well, we deploy daily, or we deploy on a schedule. We're like on a 3-week schedule or a 3-month schedule or something like that. And then sometimes I hear we do it at every check-in to source control, meaning every time we check into source control, we're build ready. We're ready to deploy. I would consider that like a high-functioning team. And I like high-functioning teams. They're attractive to me. And the reason why they're so attractive to me is because I failed at delivering a project in a big, big way a few years ago. And it was a failure that was colossal. And it kind of wounded my soul. Like, I just felt so responsible for this failure. And I'll tell you the story. So what happened was a company came to me and they said, we have a feature for our existing software that we need implemented right now. And we want to pay you to write this feature. So I said, oh, that's great. That's what I do. That's a lot of people do that. And they said, our main guys, our main developers, are too busy to do this part of our product, and it's highly important. So we want you to sit here and kind of work kind of on your own, because our other developers, our 20 other developers, they have tight deadlines, and we don't want to interfere with their deadlines to get this feature out. So you just sit here and you do this work, and then when you're done with the feature, then we'll deploy it and we'll make a ton of money and we're super excited. And I said, oh, that's great. I'm excited too. So I sat at my desk to start, I got the spec, I'm going through the spec, I'm writing code, and as I'm writing code, I realize that there are problems with their main data access layer, their main business logic, and I need to make changes to those, some pretty fundamental changes to those, in order to get my feature working properly. And so I go back to the guys and I said, look, I'm going to start changing some core things. And they said, no, you don't change. If you have to make changes, you're going to slow us down and we're going to miss our deadlines. And so what we want you to do is we want you to branch off the main trunk, and then we want you to work on that branch, and then when you're done with your feature, we want you to fold that back into our project so that we can deploy. And not really knowing any better, I was like, okay, that sounds good. I'll do that. So I sit at my desk, I branch from the main trunk, and these problems I see in their data access layer and their BL, I start modifying it. And I happily code away like this for 3-4 weeks. I've got a 6-week deadline. I'm 4 weeks into it. I'm coding away. I'm doing really well. I sit with the business stakeholders and I show them what I've done, and I say, hey, is this what you wanted? And they say, yes, that's what I wanted. That you listened to us and you did exactly what we asked for. And I said, oh, great, great. It's awesome that this thing's going to go. So the time came for my feature to be folded back into the main trunk, into SourceControl. And when I folded it back in, I got a whole ton of conflict errors, a bunch of errors that I had to resolve. And as I looked at the conflicts, I kind of realized something. I realized that they saw the same weaknesses in the code that I saw. It's just that they corrected them differently. And so I had to kind of like sort through these corrections and kind of merge them together. And there were a lot of developers on that team, and it took me a long time to figure out what was going on. And a lot of the time, I had no idea. I didn't know the code well enough to figure out why they made the changes that they made. And so I went to ask them about that, and I said, hey, you guys, can you guys stop and help me merge these things in? And they said, no, we've got deadlines. We've got stuff to do. No one can stop. We've got a lot of work items to check off. We've got people demanding things of us. We can't stop production here. And I said, okay, well, I think I can figure it out. What would happen is I'd get like an error, and I'd sit down with the developer, and I'd say, why did you write this so that I can fold my change in with your change? And they said, well, I don't know. I mean, I wrote that weeks ago. Let me think about it. And so I'd think about it. We'd thought, well, look, there were like 100 of these errors, right? By the time I resolved them all, and then I went to get latest and merge my changes in with their changes again, there were a whole new set of errors. And I learned kind of a valuable lesson. I learned that as good of a developer as I might like to think of myself, it turns out I can't outcode 20 developers. And no matter how hard I tried to catch up to them, it was just 2 more days, 2 more days, 2 more days. And pretty soon I'm missing my deadline, and I'm a week past my deadline, and I'm hearing things like, Ike, don't worry about it. You know, now that you're finished, it turns out that maybe we can solve that problem with some reports, and we don't actually need your feature. And by the end of it, I'd missed deadlines, the customer had wasted some money, and my feature was never going to get used. It was never going to go back into the main trunk, and it was never going to go into production. They figured out another way around it. And so my big question to you guys, and I know in a webinar, you know, it's kind of hard to be interactive, but my big question to you is, what was my problem? What did I do wrong? What could I have done better? And I think the main problem is, from the time I split off the main trunk to the time I folded my changes back into the main trunk, it was just too much time. I shouldn't have done that. In fact, what I should have done is I should have checked into the main trunk far more frequently. Every day, every couple of days, whatever time length I was going to check back into the main trunk, I should have done that. And the reason why I should have done that is because, well, look, the other 20 developers were fixing the same problems I was fixing, but maybe they were fixing them after I did. I mean, if I checked back in and I didn't have any conflicts, then it's their responsibility to get latest, and it's their responsibility to deal with my changes, right? So then we're kind of all in this together, and even though I'm working on a different feature, it's like we're all part of one larger team. And that's the core feeling behind continuous integration. The core feeling is that even though you're on your project and I'm on my project, but we all have this shared code base, if we're all forced to integrate together frequently, then we're all part of the same project, and we can start feeling like we're all on one larger team and we're all working together. And that's the beauty of it. So when you shorten the time to going back into the main trunk, there's less or maybe even no problems to solve. Deployment can always happen because it turns out your code might be in a deployable state, and then code on every workstation is in a build-ready condition. So here are the CI benefits. What happens when we check into SourceControl and we're prepared to build software out of SourceControl, it improves the condition of SourceControl. Source code in SourceControl, whether it's TFS or Subversion or Git or whatever it is, it has a higher quality to it because we're all using the same code. We're all getting latest, we're all making our changes, we're all figuring out a way to run some solid tests and getting it back into source code, source control, so that we can deploy out of there when we want. And when we do that, we have some benefits. Like the first one, it avoids the works on my PC syndrome. Like if I'm always checking your code out, I'm going to figure out you have an external reference that isn't referenced properly pretty quickly, because I'm going to get latest. I'm going to try to compile, and it's not going to compile. And I'm going to go back to you and say, hey, you broke the build. And if they have like a Telerik control or some infragistics or some JavaScript framework or something that they referenced, they only installed in their machine, and they didn't figure out a way to get that into source control, then that's going to be pretty telling pretty quickly. And as soon as we're all using the same code, it makes that developer's code that much easier to deploy. So all developers can get their work deployed and not be left behind. Like that's what happened to me. That's why my project failed, is I was a developer left behind. I was a man down, and it didn't seem like anybody cared to make sure that I was coming back into the main trunk. Tests can be run constantly. One of the central features of continuous integration is if we have really good test coverage and really good unit tests, then every time I check back into source control, those tests run, and that tells me that I did great. And if I did anything to break those tests, I get some red lights, people get emailed, I'm told that, hey, you broke the build. What you did was wrong, and you need to go fix it. I go fix it. I check the fixes back in, the build goes green, and then everybody knows that it's okay to check out a source control, and everything's going to work. Because I'm concerned about breaking tests, and I'm concerned about hurting other people, and I'm checking in frequently, the code becomes a higher quality. People become more confident in the code, and they feel better about it, and morale improves. We can do all sorts of kind of cool things with a good CI tool, like we can create automatic build documentation and remove unneeded files and get rid of bad dependencies, because we're building all the time, so we're hyper aware of how long that takes and when it's doing a bad job. It increases the visibility of the project. Team velocity can improve. If software is continually in a buildable state, then what that means is perhaps we can deploy more often. If we're deploying once a year, we can deploy 4 times a year. If we're deploying 4 times a year, we can deploy every 3 weeks. If we're deploying every 3 weeks, maybe we can deploy weekly. Flickr deploys, according to a podcast I heard on, I don't really know anybody in that organization, but I've heard it, and I've read blog posts that they deploy 56 times a day. And that Amazon deploys constantly. Their software is always in a build-ready state, and they're constantly deploying through the day. I heard one number I almost don't even believe, which is they deploy every 10 seconds. I'm not sure of that, because Amazon's kind of secretive about that kind of thing, but that's the rumor that I've heard. So deployment can be separate from the developers. If everything's automatic and the tests are good and we're building automatically constantly, then other stakeholders can decide when to deploy a feature based on whether that feature is ready for the business, not necessarily whether the developers are ready to deploy that feature. And then it's just the final thing is it's way easier to deploy a dev environment to new developers. Like I'm a consultant, so people pay me to come on site and work with them, and often what happens is I go on site and I basically am doing nothing for a week while I just get my workstation ready. But if you have a great CI environment, I can just get latest, everything, I install my tools, get latest, everything comes down, it builds, and boom, I'm ready to go. I'm ready to start being productive with the team in a day or less rather than in a week and a half. So that saves a lot of money. And onboarding new developers, if we're growing, it saves a lot of time and money. So I've worked with a guy. He's a great guy. His name is Llewellyn Falco. If you don't follow him on Twitter, I would look him up. And he is a disciple of a guy named Michael Feathers. And Michael Feathers is considered the de facto kind of the main guy for working with legacy code. And Llewellyn feels that way too. Llewellyn feels like there's more honor in working with legacy code than there is in writing new code. In fact, he brags about deleting code more than he brags about writing code. And so he's built this like specialized practice, and Llewellyn has worked for me and worked for several of my customers, and he's built the specialized practice where he goes and helps people get a handle on these large kind of out-of-control projects. You know, he likes to hear things like, hey, this code can't be modified because we don't know what it does and we don't really feel comfortable with it. That's the code that he specializes in getting under test, getting worked, getting modularized, getting in a place where we can start changing it. So I asked him one time, we were going to go on this shared project where we had, you know, this customer that had a whole bunch of code that they were really worried about. And I said, what's the first thing we're going to do? And he said, you know what we're going to do? We're going to tear down their production database server. We're going to tear down their production web servers. And we're going to take what's in SourceControl and what's on their UAT SQL server, and we're going to redeploy it to production. We're going to just take what's existing. We're not going to add a single new feature. All we're going to do is take everything that's existing, and we're going to put that into production. Now I ask you, I know it's hard to be interactive, but I ask you guys, how comfortable would you feel if somebody came into your organization and said that they were going to do that today? Many people, it's not uncommon, they would panic at that. And they would panic for a good reason, right? They would, because immediately their dark spots would come to light. We would say, whoa, there's modules we're not even sure are in SourceControl. Or maybe some of us are editing stored procedures in production and not folding that back into SourceControl or the dev environment or UAT. So there could be like major black spots in our production environment that if we tore it down, we might lose code, we might lose features, we might introduce bugs. And I told this to Llewellyn. I said, Llewellyn, nobody's going to do this. And he said, you know what? That is exactly how we're going to shine a light on the dark spots, is just by taking what they've got and putting it back into production. And they know what this is. They're going to tell me immediately what they're uncomfortable doing. And I'm going to make a list of that, and I'm going to make sure all of that goes to SourceControl. I'm going to make sure that all gets automated build. And once I'm finished with that, they're finally going to be in a comfortable place where those servers can go down and they can redeploy. We're going to know if their backups are working. We're going to know if their code's in SourceControl or not. And we're going to do that through the very first thing we do is building a CI environment. Now that's an amazing thing to me. And that's what we did. We spent a month doing that. And at the end of the month, we were able to tear down their production servers and replace them. But look, before we did that, what would have happened if they had had a natural failure? They were just rolling the dice, right? That SQL server was going to stay online, that their web servers weren't going to go down, that no SANs were going to go down, right? So once we were able to do that, we were able to start doing some strong changes to their code and deleting code and testing code. And once we knew we could deploy it, we knew that if it was in SourceControl, we could make changes and we could go back to a production-ready state. And that was his point. His point was, I want to be able to freely be able to make some strong changes and know that anytime I do that, I can go back and be in a deployable and a build-ready state. And there's an enormous amount of power in that. So let's focus on that. Let's focus on SourceControl for a second and the importance of making sure that SourceControl is up to date, that it's build ready, and we're ready to rock and roll. So if I asked you, if I said, right now I'm going to put a high wire 50 meters into the air. See, I speak in meters now because I'm in the UK. You know, it would have been feet or yards in the air before this UK trip. Okay, so 50 meters in the air, and I told you there was no safety net, and I wanted you to cross that high wire. My question is, how quickly would you cross that high wire? Probably pretty slow. You'd probably go hand over hand and on your hands and knees, and you would slowly edge your way across that high wire, and your heart would be racing, and you'd be nervous and sweating, and then finally you'd get to the other side. And now my question is, what happens if I told you that that high wire, 50 meters in the air, not only was there a safety net underneath you, but that safety net was fun to fall into. You enjoyed falling into it. In fact, when you fell into that safety net, you enjoyed it so much that it flung you right back up in the air, right back on the high wire, and right back exactly where you fell off of. And you loved it. Now my question is, how would you cross that high wire? You would run across it. You would skip. You would do cartwheels. You would do tricks. You would see if you could fool your friends. You would fall on purpose. You would see how risky you can be. And that's the beauty of source control. Source control allows us to fall and go right back where we were before. And when we have source control, we take high risks. And developers who take high risks are good developers. Developers who look at like a data access layer component and say, that's wrong, I'm going to fix it. You know, if there are developers who won't do that because they're afraid of introducing bugs, those are developers who don't feel like they've got good testing, they don't feel like they've got good source control, and they don't feel like they've got good CI. And so those developers get nervous in the dark spots of the code. And when you feel that nervousness, that's your gut telling you it's time to get that code under test, it's time to get that code automated, and it's time to make it so that you can change it. Because look, the name of the game in business today is change. Our businesses are changing drastically. My business looks completely different than it did 2 years ago. And every business I consult with looks far, far different than it did 2 years ago. So businesses that can grapple with an enormous amount of change, those businesses are going to succeed and move forward. And businesses that have, you know, that don't grapple with change, those are businesses that are going to fail. So when we have dark spots in our code, basically what we're saying to our business is, don't change that part. And we can't be in that environment. We're gonna contribute to the failure of our businesses if we do that. And we don't want to be doing that. So what allows us to change is source control, tests, and automation. And that gives us that safety net. And then we can take risks. And look, I know you guys are developers, right? You're DBAs, you're working with code and data all day. And I know your jobs are hard. I know what you're fundamentally being asked is to do something that has never been done before. And the reason why I know it's never been done before is because if your businesses and your customers could go find somebody who had done these things before, they would hire them, or they would pay for their software, or they would do it someplace else, right? But they can't do that. It's far cheaper if they could, but they can't, so they pay you to do things that no one's ever done before. And in order to do that effectively, you have to be able to take risks, and the only way to take risks like that is through effective source control and automation. So if we're gonna do continuous integration, we just need to be aware of some vocabulary words like a build step. A build step is just a script that runs, and it could be a script that takes a web server out of a load balancer. It could be you know, a script that automatically does a schema comparison and then deploys the schema up to the database. It could be a script that copies some files. It could be a script that sets permissions. You know, how many of you have struggled with orphan users when you deploy dev databases and backup and restore over to production? You could have a script that, you know, replaces the orphan users, right? So all sorts of scripts, and those are build steps. And what happens is we take those build steps and we execute them one at a time. And then a build trigger is what makes us build. Maybe, ideally, that source control check-in, but it could happen on a schedule. We could build every night or every weekend or something like that, depending on how large the project is. A build agent says, what can we do in the CI process? Like a build agent would be like, well, yeah, I can do a database comparison, or yeah, I can turn a web server and reboot it, or I can use PowerShell, or I can use Perl, or whatever it is, right? Build notifications are who gets told what and when. So if a build fails, who's supposed to get told? If a build succeeds, who's supposed to get told? If all the tests pass and we're ready to deploy, who's supposed to get told? Build correction is what went wrong and who will solve it. And those are basically some basic vocabulary words with CI. You guys want to hear another story? I'm not getting any feedback, so I'm going to assume that yes, it's okay to tell another story. So I started at a new customer, and I go to a developer and I say, hey, how do we deploy here? Or how do we get, you know, make development changes, how do we get to user acceptance testing, or how do we get to a deployable state? And the guy says, I don't know, that's Benjamin's job. So, oh, okay. So I go to the next developer and I'm like, hey, how do you deploy? How do you get your stuff into UAT? And he's like, I don't know, that's Benjamin's job. And I'm like, oh, well, I finally get the hint and I decided to go talk to Benjamin. So I say, Benjamin, how do you deploy? And Benjamin's like, wow. He's like, I don't know. He's like, you want me to tell you the whole thing? And I'm like, yeah, tell me the whole thing. And he's like, okay, well, here's what I do. I go make sure that all the developers have the features that are ready to deploy and checked into source control, and then I download that and then there's a whole bunch of changes, and so I have to consolidate those changes and merge conflicts together. And then once I do that, then I run my tests and I make sure my tests work, and then I have to, like, if I'm going to deploy to production, I have to, like, take a web server out of the load balancer, and then I copy some files, and then I update changes to the database, and then I put that web server back into the load balancer. I take the next one off, and I make some changes, and then I put that one in, and I do that 6 more times, and oh yeah, and then sometimes I have to change the web API layer, the SOAP layer, and then as he's talking, I realize that it's kind of like a cowboy, right? He's just kind of doing it as he thinks of things to change, he changes it. And I said, Benjamin, how long does this take you? And he's like, oh, it takes me anywhere from 2 hours to 8 hours. Sometimes it takes me overnight. I'm like, wow, that's a big range. And he's like, yeah, well, I get bugs and the users complain and I have to fix them, or I have to go get the developer and figure out what we did and make sure everything's good. And sometimes I forget a step, and I make a mistake, and it's just kind of a nightmare. In fact, I hate this part of my job. And I said, well, if you don't like this part of your job, we can fix that. We can change that. He's like, really? I would love to make this better. And I said, well, look, let's start with just the file copy. The file copy, do you ever miss some files? And he's like, yeah, all the time. And I said, oh, we can automate that. That's just a script. Let's write the script. So we wrote the script, right? And we made our mistakes with the script, but when you improve a script, you improve it for life. So when he made a mistake without the script, he could make mistakes in new ways every time he did it, right? But if he scripted it, every time he made a mistake, he could fix the script, and it was permanently improved. And that script, just over time, just kept getting better and better and better as time went on. And so pretty soon we figured out that we could script the load balancer, and we could move things in and out of the load balancer too, and we added that to his build process. And then we figured out that we could deploy the database changes and script that out, and we added that to his build process. And it took maybe a solid 6 months. And you know what happened is his deployment process went from like 8 hours to like a consistent 4 hours. And then, maybe about 4 or 5 months later, it went from 4 hours to 2 hours. And then a few months after that, it was going down to about 15 minutes. And pretty soon, he could just click a button and deploy. And then Benjamin went from having a job he hated to a job he loved. And he went from having a job where he made mistakes and people thought he was an idiot to being a hero. And that's the beauty of scripting and continuous integration, is that we can enjoy deployment. And I would say that's a huge attribute of a high-functioning team, is a team that enjoys deploying. They want to deploy the changes they've made as often as possible, and that makes them a frequent deployer, and that increases the velocity of the product, and that makes people love that team. So CI products are out there like Cruise Control, Hudson, MS Build, or TeamCity, and then there's a product that I'm going to show you, Redgate CI for databases. I don't work for Redgate, by the way, and I don't get paid by them, but I just want to show you this one part. It's a plugin for TeamCity. So there are some CI disadvantages in the interest of fairness, right? It takes a lot of time to set up. You have to write these tests. You have to put effort into it. Somebody needs to be in charge of it. Your build time should be short, and to shorten build times, if you're going to get good feedback and you need good short build times, it can take a long time to make your build time go from 45 minutes to 3 or 4 minutes, right? And then sometimes there's wounded pride, like CI will tell you exactly who's not checking into source control. It will tell you exactly who's not getting their features out, and as the team velocity increases, you might leave a department behind, and the leader of that department might not like that and might fight against CI, so just be aware of that, right? So, basic CI architecture is you have a dev environment, and then you automatically build to UAT environment, and then you automatically build to a production environment, like kind of what I've been describing the entire time. And so this is just an example of a CI process. So step 1, you check in from source control. And so I'm checking in, right? I've made my changes, boom, boom, boom. I check into source control, and that launches a build trigger. The build trigger begins the build, and CI takes over. It runs the tests. It does 15 things that you've decided to automate. And then it gives a green light. So, okay, everything worked great. CI built the solution, ran all the tests. copies the data to the UAT server, and then CI notifies everybody that, hey, there's a new build that's finished, now you can go get latest if you'd like. And then everybody gets latest, and everybody's got a build-ready software, and they're ready to rock and roll. So here are some CI best practices. So we check in several times a day. We merge changes at every check-in. We, don't break the build. So, remember the merge changes at every check-in? That was my problem. My problem was I coded for 3 weeks. When I went to merge, it was overwhelming to me, and it slowed me way, way down. So don't break the build. Get latest, merge, run tests, build, check-in. If you broke the build, tell everybody about it so they can stop getting latest from SourceControl. Don't check in until the build is fixed, and then once the build is fixed, notify everybody that the build's fixed and they can go get latest again. So there are some problems with the database here. I mean, SourceControl's hard on the database, right? Like what a lot of teams have to do is they have to script. So they're not allowed to use the GUI, or if they do use the GUI, they have to script every change they make, and then they check that script, that file, into SourceControl. And one of the problems with doing that is it relies on people obeying the rules. And hopefully they do. If they don't, maybe there's strong leadership that enforces the rules. But sometimes, the beauty of stored procedures is that they're just so easy to change in production, aren't they? So we sometimes do it. And that's not a good practice. Sometimes we think that indexing and performance tuning is not part of the business logic, and so they don't get replicated in SourceControl, and they should. If we want build-ready systems that are ready to go, that indexing needs to be part of SourceControl. So, we want dev and test to be the exact same as production, not different. Change management has been very difficult. Making sure that schema and data changes go when they need to go has been very, very difficult to do correctly. Writing stored procedures and functions and SQL tests, testing databases, that has been a very difficult thing to do in the past. We've got some stronger products now, but still it's been a hard thing. Comparing values with separate stored procedures, changing data that's changing out from underneath us, all of those things make testing databases very difficult. Not only that, but we don't have really resharper in a stored procedure like we do in C#. Like resharper, if I write a test, I click a button and it frames out the method for me. It gives me a method signature. And then I can go immediately into the method signature and fill it out so that test pass. We don't really have that same type of functionality in SQL Server and SSMS, right? So basically, if you want to bring your database into a CI or SourceControl environment, you really have to be willing to fight for it. You have to put some effort into it. And I'll be honest with you, what I'm about to show you, it isn't perfect. There are things I don't like about it. But it's better. It's getting better than the way it has been in the past. And I think it continually improves, right? Okay, so I'm going to show you TeamCity, I'm going to show you Redgate, and I'm also going to show you sequelT. So why don't we start with SourceControl, and then we're going to go to testing, and then we're going to go with CI. Does that sound good? So let's just kind of play around with it for a little bit, all right? So the first thing is, before I show you the SourceControl product, let me just go into Notepad real quick and just kind of talk to you about a build process that we have. It's hard when I don't have a whiteboard, but let's say that we version our software, right? We write software, and our software has a relational database. We have a SQL database here, right? Okay. And then let's say that we're on version 6.7 of our software, right? And our goal is to get to version 7.2. That's really what we want to get to, right? So let's ignore what's happened before with all the other versions that got us to 6.7, and let's just say we're starting at 6.7 and we're going to 7.2. You with me so far? So what we're going to do is we're going to create a full script of the schema and data of the database. We're a commercial product, so we're not really worried about migrating data from previous versions at this point. Remember, we're going to ignore what happened before. We're really going to worry about, selling our software at version 6.7, and when we sell it to a new customer, they run this full script. It creates the database, it creates the schema, it populates the lookup tables, it does all of that. Okay, so we're starting right there. Now, as every developer makes a change, they script it. They script a bunch of tiny little scripts. And then they take those scripts and they check it into SourceControl. So what you'll see is they're working on the next version, so you'll see version 6.72, then you'll see like a work item number, 11521, and then you'll see like, adding birth date. And then the next guy is going to say, okay, I'm version 6.72, I'm 11152, I'm dropping bad audit table. Okay, so you're going to get all these kind of little tiny scripts going in, and when the time comes that you're going to go to version 6.8, then the build master is going to take these little scripts and consolidate them into one Delta script. And that's going to take a lot of time, and the build master is just going to have to fight for it. I mean, there's no easy way to do that. And then in addition, the build master is going to regenerate the full script. So now he's got two scripts. He's got the script that we sell to new customers, so we install it brand new, and then we've got the Delta script that gets applied when we're going from 6.7 to 6.8 so that our customers don't lose any data, and they get all the new features and everything works fine, and we migrate effectively. So, and then now we go to version 6.9, right, where we get all the little scripts as we work on it, and then the build master gets involved again, etc., etc. Okay, that's a lot of work, and sometimes there's just no way around it. And I'm kind of simplifying, what could potentially be a pretty complicated process, right? But that's a workable solution for SourceControl. You script everything. You script tables, you script store procedures, you even script the data. If you're populating a lookup table, you even script the data for populating it, and you keep that script updated. And you can do that. Now that's one way of doing it. Another way of doing it is, and like I said, I'm not hawking Redgate, but Redgate has a product called SQL SourceControl, and it's part of their development bundle. And unfortunately, it costs money. But what it does is it'll put a SQL server under $4.95 a user, so it's kind of expensive. But it will put it under SourceControl, and it integrates. Like, let me just show you. If I right-click and I say Link Database to SourceControl, it uses Git or Mercurial or Subversion or TFS or Vault or a working folder, so you can use some type of Explorer plugin or something like that. But so it integrates with all of these things. Now I'm using Subversion, so I linked mine to Subversion. And the way I know that it's linked is, can you see when I scroll in like that? I don't know if you can see that green, SourceControl Demo 1. That green database is now under SourceControl. And now what I can do is I can come in here and I can say, oh, for my tables, my sales table, I'm going to look at my columns and I see SysID, I see sale date, I want to see employee ID here. So I'm going to click maybe a new column, and I'll say employee ID, and it's an int, and it allows nulls, and I'll go ahead and click Save, and I'll close it out. Now, what I'm going to do now is I'm going to right-click on SourceControl Demo, and I'm just going to commit those changes. And so I'll say, adding imp ID to orders. And it says, oh, look, I see, or to sales, excuse me. Oh, look, I see a change. Look, from SourceControl, there's a change here. Do you want to check that change in? Yes, I do. So anybody who's played with Subversion is used to this this UI. This is going to feel comfortable to you. You're going to feel like you know this, right? So you're going to say, okay, that's fine. I'm going to go ahead and commit. And it goes and it checks everything, and it looks at the script, and it commits that change to SourceControl, and it says, okay, I did it. Click OK, and now we're good. No objects with changes to be committed. We're all good. So now pretend like I'm over here, and I'm not pre-baking the turkey here. If I click on my sales and I click on columns, I only see SysID and sale data. I don't see that employee ID, do I? So pretend I'm another developer. I can just right-click out of SourceControl and I can say Get Latest. And it scans my database and it says, hey, I found a change in sales. SourceControl has employee ID. You don't. Do you want it? And I say, yeah, I absolutely want it. So I click on Get Latest. It applies all the metadata. I click OK. It runs the scan again and says, looks like you're good to go. Everything's current. And that is how SourceControl works if it's integrated into SQL Server Management Studio. It's pretty cool. Okay. So that's another way of doing SourceControl. Now, if you and I were in the same room, I would ask you this question and say, what are you guys doing for SourceControl? Because I'm not happy at paying $500 a user, or I don't, there's some problems with it. Everything's not perfect, right? Or I don't like the versioning thing. I mean, it's a lot of work for the build master to consolidate those scripts, and that guy has to be either a DBA or he has to work closely with the DBAs, and I want to know what you guys do. Like, I want to know how you guys do your job, and if you've got a better solution than I do, I would love to hear it. I'm always looking to improve myself. So, and if you give me something awesome, I'll share it with the world. All right. So that is SourceControl. Now let's move on to testing. I said that was our next thing. Testing. This is an open source framework for unit testing a database called sequelT. Now, I think a lot of you might have heard of this before, but in case you haven't, sequelT is a database unit testing framework for Microsoft SQL Server. It's compatible with SQL Server 2005, SP2, and above. And it has good documentation, and you just download it. And when you download it, it's just a zip file, and that zip file just has, you enable the CLR, and then once the CLR is enabled, you run one script, and that one script, here's what that one script does. This is by sequelT example database that I used. It creates anything with the sequelT schema it created. It creates all these sequelT functions and procedures that help me with unit testing. It helps me with database mocking, table comparisons, all sorts of stuff. Now, a few things that you need to know. So I'm going to open up a new notepad here and just kind of free-form talk to you guys. All right. So a few things that you need to know. When you do unit testing, particularly if you do TDD, test-driven development, you tend to follow a pattern. It's called AAA. You arrange, some people call it a symbol, you act, and you assert. And what that means is, in arrange, you build your environment. Like you say, okay, I'm going to instantiate these variables, I'm going to build these classes, I'm going to create this database, I'm going to do whatever I have to do to make my environment the way I think it will be in production. And then you act. And this is usually like a procedure call, or a function call, or a method call, and you get results. And then what you do when you assert is you compare those results with what you expected. And if the results happen the way you expect them to happen, then you get a green light. It says, hey, the test worked and you did great. And if the results don't work the way they expected, then you get a red light. And if you do test-driven development, you're writing these tests before the actual code is written. And so you run the test immediately and it fails immediately because the code's not written yet, but it kind of drives you to make sure that that test works and that it complies with the spec, it complies with the work item, and the test works, and you write code that's fluid. And even better, that test now becomes part of your source control in your build process. And so in your build process, you will call these tests, and if anybody at any point, like you write these tests in March, and if in October somebody writes code that breaks those tests, the build server will run those tests and say, hey, you broke something. And then that person who wrote that broke it, can go back in and say, whoa, I didn't realize I had these side effects, or I messed with some regression, or, I apologize, I'm going to fix the test that I broke, and then check everything back in and do all the great things that CI will do for you, kind of like we outlined, right? Like that's the beauty of all of this, right? Okay, so remember that test-driven development, we do this arrange, act, assert constantly. Okay, So first off, let's close source control. Let's go to T-SQL-T, and what I'm going to do is I'm just going to run my tests. And the way I do that is I just do T-SQL-T run all. Okay, here's another thing. I just realized you're going to need another thing. We're dealing with some schemas here. Schemas. And the schemas that we're dealing with are, number one, we're dealing with T-SQL-T. T-SQL-T. Why can't I type today? Okay. And T-SQL-T is, this is the testing framework. So this is what I use to have all these helper methods that help me have a great test environment. And then the next schema is my testing schema. And I register this with T-SQL-T in order for T-SQL-T to know what test to run. And finally, there's my production schema, whatever I call that, right? And that production schema is called by my testing schema. That's what I'm actually testing. So T-SQL-T, you register the testing schema with T-SQL-T. The testing schema calls a whole bunch of procedures that are in your production schema, and now you know your production schema is rock solid and ready to deploy. And I tell you this in the database because there's the T-SQL-T schema right there, right? See these? That's how we know. That's T-SQL-T schema. And then right here, this is the accelerator test schema. And then accelerator test is testing things in this accelerator schema. And this is right out of the documentation on T-SQL-T. So you can run this anytime you want. I'm just really quickly kind of showing you. So in T-SQL-T, we have this run all procedure. And if I execute the F5, it gives me results back here that will look, if you guys are Visual Studio developers, this will look like in-unit or MS Build to you. And it says, hey, test case summary 11 executed, 11 test cases executed, 10 succeeded, 1 failed. Which one failed? Well, if we look back, it's this one. It's this test ready for experimentation if 2 particles. So one thing is we name our test something that lends itself to knowing what failed. We're like, okay, let's go ahead and take a look at that thing. So I come into my accelerator test and I look for test ready for experimentation if 2 particles. And I right click on that thing and I modify it. And I look at this and I say, okay, look, remember this? Remember when we said arrange, act, assert? Look what I'm doing. Here, well, assemble. So exact, okay, I'm adding 2 particles. That's what it said, 2 particles. So I'm adding 2 particles, and then I'm declaring my ready bit. That's my assemble. Now I act. I say accelerator is experiment ready after I've inserted these 2 records. And then I think that assert equals 1 is at ready. Like, it should be ready after I insert these 2 things. But for whatever reason, it's failing on me. And I could just execute this all by itself if I wanted to and see the result. Or what I can do is go into my act, my is experiment ready. This is select. This is a function call, right? This is a scalar coming back to me. So I can go into my functions. Here's my scalars. I can go say is experiment ready, click modify, and it says, oh, look, num of particles is int, num of particles equals count 1 from accelerator particle. If num of particles is greater than 2, oh, here's the problem. I'm only adding 2 records in my test, and this is expecting more than 2 records. So I either need to add another record, or if my test is genuinely, you know, when you add 2 records, that means the experiment is ready. That needs to be an equal sign. So I changed that, excuse me, can't type. So I changed that to an equal sign. I F5, I go back to my run all, and I get nothing but good, right? Look, 11 tests executed, 11 tests succeeded. You guys can run this yourself by just using the online tutorials for T-SQL-T. Now, just to show you something, Redgate created this thing called sequelTest. And this sequelTest, if you say, hey, run all the accelerator tests, you can run them all, and they all go green right here. And if this one was red, remember this one was red before? I double-click on that, and it takes me right into the test, just like you saw before, and lets me modify it. Now This actually looks an awful lot like InUnit or MS Test or any one of the other testing frameworks that you use. They all kind of look the same. Okay, so that's sequelT. Okay, and you saw you don't need sequelT if you just want to work with code. I mean, I work with sequelT and code all the time. It works just fine. Okay, now what happens if we want to like build it ourselves? Remember, we're coming back here and we're saying, look, here's my sequelT testing framework. I want my testing schema and my production schema, right? So what I can do is, let me close this out. Hey, I learned something this week. Did you know that if you want to close a window and you're done with it, you can just center click your mouse in any environment in Visual Studio? Like, this is my scroll bar. I'm just clicking it and it just closes it automatically. How awesome is that? You can do it in Chrome. Anyway, apparently people have known this for years. I didn't know this. Okay. So remember, what I'm doing is I'm creating that try it out schema and registering it with sequelT. So if I click execute here, it builds the schema. And now I'm just going to create a couple of tests. This is test this causes a failure, sequelT fail. This is what a failure looks like. So I execute that. And then test this one, it passes. So sequelT assert equals 3. This is quick math, right? Sum equals 1 plus 2. I expect the sum to be equal 3. And that's assert. And if you've done like asserting an InUnit, you guys know that it's debug.assert. And this is just sequelT.assert equals. And you've got all these different asserts that you can play with right up here, right? Assert equals string, equals table, equals like, all that stuff. So, okay, I'm going to take that. I'm going to execute it. And now if I go back to sequelT or I go to sequelT and I just come up here and run my tests, oh, actually I've got this new schema. I should have done the whole thing, but this new schema, try it out. I run my tests. Look, I get one green, one red. I double click it and it takes me right into the red. That's pretty neat. Okay. All right, so we talked about source control. We talked about testing. Now, before the hour is over, we want to talk about continuous integration. So we come in here, and I just kind of show you TeamCity. Uh-oh, where's my TeamCity? I thought, oh, I have it right here. Perfect. Okay. So TeamCity is free, by the way. You guys can download it and use it for small projects. As your projects grow, then you have to pay for it. But it's a pretty UI, right? I like this thing. And if I want to run, remember, what I'm doing in CI basically is I'm just scripting stuff out. That's it. I'm running tests by script. I'm building by script, I'm copying files by script, I'm deploying database changes by script. All that stuff is happening by script, right? And so remember when we talked about, all the way back here, we talked about some CI, what did we say? We said here are some, where is that? I had, there. Remember these vocabulary words, build steps, build triggers, build notifications, and so forth? Look at build failure, build triggers, build steps, build parameters, agent requirements. So you're seeing some of those vocabulary words right here. And if I click on this build step, notice that I've got all sorts of build steps I can do here. These are my agent types, right? I can run code analysis in FXCop. I can inspect. I can use, MS build or MS test if I want to run tests. I can use InUnit to run tests. I can use PowerShell or I can use Redgate. That's what I'm using right now, is I'm using Redgate, right? So I'm going to go ahead and edit this. And it basically says, okay, your runner type is this Redgate, and I'm going to call it build UAT. And if all previous steps finish successfully, then, do something, exit or go on to the next step, right? And then, okay, my database folder is in SourceControl. Here's how you connect to it. It's build to my local host, and what I want you to do when you build is go to this database, go to CI demo UAT version 2, and automatically run any test registered with sequelT, just like you saw that try it out, it automatically registered, and then sequelT automatically ran it. Well, guess what? The CI can run your sequelT tests automatically, and then you can do a whole bunch of other things. Okay, I've already configured this, and the build trigger, just so you know, it's one build per VCS check-in. And so remember, when I came back here, these green databases, I checked this stuff in already. And because the build takes a long time and I don't want to waste your time with this, I have that CI demo UAT version 2. It's not under source control, right? That's the CI. You don't want your UAT under source control, right? That's what your build server is going into. You want your build server deploying into that so that your UAT, your users can start playing with it to tell you that, yes, they want that feature. So this happened already automatically, so you don't have to wait. And look, if you have tables, if you have sales, if you have columns, look, employee ID. I added that in front of you. And then in the background, the build trigger kicked off, it built, it ran tests, and then it deployed that automatically to UAT version 2. And that's how continuous integration with the database will work. There's obviously a lot more complexity to it. You can research it if you'd like. The basic thing is you've got to get good at comparing schema and data and then somehow packaging those changes up to build scripts and then deploying that to the server. And whether you use the tools I showed you or you write that yourself, that's the main thing you're trying to grapple with when you get the database under CI. And that's it, you guys. Thanks for spending an hour. It's 8 o'clock at night. I got to be up at 3 in the morning to fly back to San Diego. Manchester's so rainy. I'm kind of glad to go back to San Diego. But look, if you want to get a hold of me, you can look me at my blog or check my website. I make some YouTube videos sometimes. I try to make 3-minute tips. I'm the virtual chapter leader of the SQL Past Book Readers chapter. That chapter, we just read books together. So we pick a new book every 3 or 4 months. Right now we're reading a Hadoop book. And if you want to learn Hadoop, our next meeting's in a week and a half. You just need to read the first 200 pages, chapters 1 through 6 of Hadoop, the Definitive Guide. And you can meet with us, and we just meet and talk about it. There's 6 or 7 of us that like to meet and talk, and you're more than welcome to come hang out. Go to our GoToWebinar. You can look at our old videos online if you'd like. I'm the leader of the San Diego Tech Immersion Group, the founder. It's the largest user group in San Diego. We have about 150 active members. I tweet at Ike_Ellis. You can call me or email me. I'm a pretty friendly guy and more than willing to talk to you. Hopefully you enjoyed this hour. This was a good use of your time, and I look forward to getting to know you maybe at the next SQL Pass Summit. Thanks a lot, guys. Oh, question. Okay. Can you handle deployments at any time to a production environment without affecting customers? Zero downtime. Well, I mean, that would be the goal, right? That's what Flickr and Amazon do. And, you know, ideally that would happen, but it takes a lot of work and effort to get to that. You know, continuous deployment is what that's called. And, you know, it probably started with some high-functioning groups in 2010, and they're getting better and better at it. And you can listen to a lot of podcasts about it. I use Subversion and I use Redgate, but I'm getting better with Git, and I'm starting to like Git a lot more. And by the way, TFS and Git are not mutually exclusive. You can use TFS for work item management and Git for source code repository. But whatever you do, I would do it cloud-based. You know, my preference is that I can get to my source code whenever I want, and you know, no reason to host your own servers anymore, right? Looks like people are dropping off now, so I think we're about done. I hope everybody, what do I think about a project-based database development in SSDT? Well, a lot of people like that. I've seen it. You know, I kind of learned to not work with it, but there are some things in SSDT I really like. Like, I like that the scripts are automatic and that you can check them into source control right there, and I think that's really cool. I also like that, like, Management Studio is kind of messy, right? Like it's all, you've got all this stuff nobody really uses, right? And when you look at like an SSDT project, you register a server in SSDT, you know, things do seem to be like right kind of clean in front of you, right? Tables, views, for procedures, functions, pretty much everything you would need, and you bypass all the security and all the other nonsense that developers just don't care about. And the comparison tools are cool too, right? They're like tools, SQL Server, and you can like do a data comparison or a schema comparison, and they're pretty solid. And then deploying, I'm not integrated with TFS or source control here, so I can't really show you deployment. But, you know, I think it's getting better. A lot of people tend to like it. It's not what I use, but I don't think there's anything wrong with it.
I guess that's pretty much it as far as the questions are concerned, and we really do appreciate your time, Mike. This was a great presentation, and, you know, everyone's... they saw your information up there. If you can put up your last slide one more time in case anybody wanted to jot that down.
Sure. Screenshot that, yeah. Yeah,
I appreciate that. And lastly, we will have this this presentation available in our YouTube page, and You can get that information again at the pass app at the appdev.sequelpass.org website. Thanks again to all the participants, and Ike Ellis, thanks again for a great presentation.
Yeah, you bet. My pleasure. Thanks, guys.
All right. You guys have a good weekend. Bye-bye.
Yeah, you too. Yeah.
Bye.